Okay, the 2 points 8, 4 and 2, 2, the ends of a diameter of a circle C. So I'm going to sketch a circle here, okay, with my compass. Okay, so we can kind of get an idea here of what's going on. Alright, so we've got these 2 points, so we'll put, say, 2, 2 there, for instance, okay, and they at the end of a diameter. So remember, diameter goes all the way across the circle, okay, and through the center. So it goes through the center, through my pin there, where I put the pin, and it takes me to the other end of the diameter, which would be the 0.84. So it's asking for then the equation in part A, the equation of the circle. Now to get the equation of the circle, you need 2 things, don't you? If you remember, you need the circle center, okay, and you also need the radius. Okay, so those are the 2 things you need. Now it's quite straightforward to get the circle center because you've got the 2 end points here of the diameter. Circle center is going to be in the middle of these 2 points. Yes, to get the middle of those 2 points, we just use the midpoint formula that we learned in coordinate geometry. So if you remember, so the center, we'll just call C, will be using this formula, x1 plus x2 over 2 is the x value, and then y value will be y1 plus y2 over 2. So you add the x values, so in this case it'll be 2 and 2, 2 and 8 rather, 2 and 8 for the x values divided by 2, and you add the y values, 2 and 4 added divided by 2. Okay, so we get our answer out to be, well, that's going to be 5, and that's going to be 3. So there's my circle center there. Okay, so I've got the circle center. I now need the radius. Okay, but the good thing is the radius, if I work out the diameter, I can just halve it, can't I, to get the radius. So if I work out the diameter length, okay, that will equal to, well, using the other formula we learned from coordinate geometry, based on Pythagoras' theorem. Okay, you've got x2 minus x1 all squared, take away, plus then y2 minus y1 all squared. Okay, so in this case, well, the x values are 8 and 2, so we'll do 8 take away 2. If I call that my x2, y2, I'll call this my x1, y1. So it'll be 8 take away 2 squared, and then we've got, being consistent, the y2 there, so 4 take away 2 all squared there. So we can use our calculator on this. Okay. We get out 2 root 10. Okay. Now that's the diameter, of course. Remember now that's the distance all the way across. To get the radius then, you've got to halve that diameter, yeah? Okay, because that's the whole way across. The radius is going to be half of that, so it'll be 2 root 10 divided by 2, and of course that just comes out to be root 10 then. Okay, so the equation circle, and remember the equation of the circle follows the format of x minus a all squared plus y minus b all squared equals to r squared, where a and b are your circle center. So it'll be circle center 5 for a, b is 3, and then the radius squared. Now the radius is root 10, so when you square root 10 you get 10, yeah? Square root of root 10 is just 10. Bro, so there's our equation of the circle. Part B then, they ask for the equation of the tangent to C at the point 84. So if I go back to my circle here now, right? The tangent, of course, just touches the circle, okay, at that point. Touches it, like that, yeah, that's what a tangent is. And you know with a tangent, it's actually perpendicular to the radius, okay? They're perpendicular to each other. So the way I would go about this is, because I now know the circle center to be 5, 3, if I work out the gradient, okay, right here from circle center to the 0.84 there. If I work out the gradient of that, I can then work out the gradient of the tangent because they're perpendicular. Once I've got the gradient and a point, I can do the equation. So if I work out the gradient here of the radius, which remember is the formula y2 minus y1 over x2 minus x1. Okay, so that's the gradient formula. So using these points here, so my y2 will be 4, my y1 will be 3. And then my x2 will be 8, my x1 will be 5. So I get 1 on the top, 3 on the bottom. Now that's the gradient of the radius, yeah? It's the gradient of the radius here, but I want the tangent. So remember the tangents are right angles to it, so we can use the rule then, m1, m2 equals minus 1. Okay, so then because the first gradient is a third, the one of the radius, you will then get the m2 then has got to be, well, you can take that third over and divide. So then you've got the third on the bottom, so flip the fraction, take the 3 up, so you get minus 3. So that's the gradient then of the tangent. So to get the equation of the tangent, we know the gradient is minus 3, and we know it goes through that 0.84, yeah? Okay, so it goes through that 0.84. So we can do then y minus y1 equals mx minus x1. So we'll have y minus 4, gradient minus 3. So it's a case of then simplifying this. Okay, so we'll have 3x plus y minus 28 equals 0, and you get everything onto one side. Now we're done, we've got the equation now for tangent.